Okay, so hello everyone. I'm Rachel Bleiman here with Jamie Williams, and we are presenting about our paper titled Exploring the MITRE ATTACK Matrix in Social Engineering Education. All right, the rest of our co-authors aren't with us today for this presentation, so here's just a little bit about myself and about Jamie. I am going into my third year as a PhD student studying criminal justice at Temple University in Philadelphia. Some of my research interests include myths and disinformation, social engineering, cybercrime, and online privacy. I've been working for Dr. Anshul Regge in her cybersecurity lab for a couple of years now. And lately, we've been focusing on cybersecurity education efforts. And I'll let Jamie go ahead and introduce himself.
Thanks, Rachel. Jamie Williams. I work for the MITRE Corporation, where we do research and engineering revolving around cyber. Particularly, my role, one of my roles, is the lead for Attack for Enterprise. So, basically, as we'll kind of get into later, a lot of the medium that we use to describe this case study and this research. But outside of that, a lot of my research is around, red teaming, adversary simulation. So kind of the background of this particular research, as well as threat intelligence. So looking at what real actors are doing and hoping to decompose that, but also figure out as defenders, what are we going to do about it?
Sweet. All right. So today we'll walk through a few things together. I'll start with some background on social engineering. Then Jamie will talk a bit about the MITRE ATT&CK framework. We'll then bring those two concepts together to explain this experiential learning project that's developed for students. And we'll go over some of the results and lessons learned from that project, as well as acknowledge some of the biases and limitations. All right. So for anyone not familiar with social engineering, or SE for short, it's typically defined as any act that influences a person to take an action that may or may not be in their best interest. So this covers things like phishing emails or scam phone calls that we all pretty much see every day. And social engineering is so important because it allows people to target that human factor in cybersecurity. And that human factor makes cybersecurity so much more than just technical. Right, a business can have the best technical defenses around, but if an employee clicks on a phishing link or allows someone to enter their server room, then those technical defenses don't really stand a chance. And social engineering does have a real impact. This statistic from 2020 from the FBI's Internet Crime Report noted that the financial losses from just 3 types of social engineering, which were business email compromise, phishing, and romance scams, all totaled more than $2.52 billion in financial loss in 2020. So clearly, social engineering is a problem. Despite knowing that the human factor is often leveraged via social engineering attacks, cybersecurity education has pretty much continuously focused on the technical aspect and pretty much neglected social engineering. And this neglect can have, a profound impact on the state of cybersecurity, especially as it's estimated that there is a global cybersecurity workforce shortage of about 2.7 million workers. Many students find themselves believing that, if they don't know how to code, then they can't be involved in cybersecurity. But by embracing social engineering as a legitimate means of preventing cyber attacks and providing sufficient education on it, some of these roles could be filled by those who specialize in social engineering and who understand the psychology of how adversaries think and behave. The workforce does get trained on social engineering awareness, but it's rarely taught in schools, which doesn't really make sense or add up. And this is kind of where our cybersecurity lab fits in, as one of our areas of interest is social engineering education. And one of the ways we've taught social engineering is through an experiential learning project, which is the focus of our talk today. This proof of concept project has students map a social engineering case study to the MITRE ATT&CK framework. And Jamie will talk a bit more about the ATT&CK framework now.
So the ATT&CK framework is, in long story short, is a way that we use, a model that we use to describe and track adversary behaviors. It is globally accessible and freely available, so something that everyone here can go check out for themselves. But just to orient you to what we're looking at, This is what we typically call the matrix view. So going across the top in that blue column, we have what we call tactics. Those are going to be adversary goals, basically thinking why an adversary does what they do. Are they trying to, do reconnaissance on a target? Are they trying to gain initial access, dump credentials, et cetera, et cetera? What separates attack from a typical kill chain is going to be those adversary goals. We don't prescribe linear order, so we're not saying every campaign or every effort is going to go left or right. The other thing that separates attack from typical cyber kill chain is going to be coming down from those adversary goals. We have what we call techniques. Those are going to be how an adversary would actually achieve that tactical goal. So are they going to do initial access via phishing, via trusted relationship, et cetera, et cetera. So it was really great to see, this case study run through this lens, because what this really enables us to do is not only, paint a clear picture of a case study, we're looking at, adversary behaviors and really getting a clear picture of it, but also start to define a common language where we're bringing in a bunch of different perspectives, a bunch of different, ways of looking at a problem, and really starting to figure out, are we actually looking at the same thing? Are we talking about the same thing? But also being able to compile all those thoughts into a reasonable, a thread where, the way I interpret something may be different than the way Rachel interprets it. But if we can point to the same picture on a map and say, we're both trying to defend this, we're really thinking about the same thing, we can really start to collaborate and, really get our ideas together. Next slide, please. But as Rachel said, we kind of fell to that same bias of, attack is very, very much tailored toward technical behaviors, thinking, what an adversary would do to a network or, a host or some type of computer. But that said, thinking about back to, myself included, I learned a bunch during this entire process about the true influence and the true scope of social engineering, thinking about things like, persuasion, manipulation, elicitation, all of that is going to be inherent in attack. So even though we don't have an explicit tactic or a specific technique for social engineering, as you look across the matrix and across various tactics and various techniques, you see very, implicit components of social engineering that are just, part of the way this behavior is either executed or, actually achieved in terms of successful execution. So that was, a big realization. I think that's something we've been kind of noodling around for a while, is how important that human factor of a system is in terms of, an adversary could do a technical behavior such as send a spear phishing email. But really, what makes it actually, tangible and materialize is that lure. How good does it actually look? And that human social engineering factor of, that interpretation of, does this look real? Is it something I want? Is it worth, all kind of disregarding all that training we all get on don't click links, don't do that, and really bypassing all those controls in order to, whatever that lure is, really, take advantage of that. So that was, this research is really fascinating to us, not only just for the case study of watching a different group map to attack, because that in itself is a really interesting science for us to really understand, is how people actually use attack, but also, really, like Rachel was saying, starting to cross-pollinate these really two important domains in terms of social engineering and cyber. We know those overlaps exist, but having tangible evidence that actually starts to show, here's the exact places they exist, but also, bigger picture, like I said before, the bigger picture of attack is understanding, what are we going to do about it? So really thinking about, now that I can kind of see it and I can kind of feel it, how, as a defender, can I be better at, case in point, what I was just saying of, we looked at attack and we're like, these behaviors that are very social engineering focused, very often the only mitigation we could think of was user training, tell people not to do that, slap the wrist, tell them, kind of keep them informed. But really, as practitioners and researchers, we can start to ask tougher questions. That's clearly not everything. There's definitely some more that we can do, but until we actually venture into the space and map it and codify it, we'll never truly see it and be able to share it and broadcast it to the broader community. So before we even get into conclusions, we were just pretty giddy about, getting into this and actually seeing, in the spirit of research, tangible evidence that starts to cement some maybe best practices and improvements we can have in the future.
All right. we talked about social engineering and we talked about the ATTCK framework. So now we can bring in this experiential learning project and put it all together. So this project involved mapping a social engineering case study onto the ATTCK framework that Jamie just described. And it was implemented in Anshul's class. It was an upper level undergraduate criminal justice elective called cybercrime. And the class was filled with multidisciplinary students, a lot of criminal justice or other liberal arts students, as well as a lot of science and technology students, like computer science majors. And this mix of students was really great because, those non-technical students got to experience being involved in cybersecurity. And the technical students had a chance to understand, the importance and impact of social non-technical skills in cybersecurity. And this project was implemented twice, once in fall 2020, and then immediately afterwards in spring 2021. And usually Anshul's class does a lot of physical, hands-on social engineering projects. So this worked really well as an alternative that could be done virtually since we were online due to the pandemic. So a brief rundown of some more of the project details. This was a two-part group project. The first part required students to identify any attack tactics, techniques, or sub-techniques, which we saw in that matrix a couple slides ago. So any of those that they could find from their given social engineering case study. They then had to identify the proportion of each tactic that they were able to map. So how many techniques out of the total number of techniques for each tactic. And not every group was assigned the same case study, but there was some overlap. And the results that I'll go over in the next couple slides are from 3 groups across both of the semesters that read and mapped onto the same exact case study. Jamie also did part 1 of this project and created a mapping for it too. So Jamie, feel free to jump in at any point with any comments. But here's an example of some student work for part 1 of this project. So you can see the group's mapping along the bottom. So some tactics were mapped to multiple times, like reconnaissance, we see here a good number. Others were not mapped to at all. This group here mapped to T1589, gather victim identity information. And for part 1 of this project, they had to provide evidence from a quote from the case study to justify their mapping. So the quote that they were able to find for gather victim identity information was that Tim, who was the social engineer in their case study, Tim went full bore collecting information such as the email layout scheme, open requests for quotes, all employee names he could find, plus any social media sites they belonged to, papers they wrote and published, clubs they were part of, as well as service providers they used. So the group had to supply a quote like this for each technique or sub-technique they mapped to. And they also had to justify how that quote matches to that technique and is evidence for that. So that's kind of what part 1 of the project looked like. And we have a glimpse at part 2 of the project, where again, students had to identify the proportion of mapped techniques within each tactic. So along the side here are all of the different tactics. And then we have the 3 groups. So the highlighted numbers that we see were those tactics that a group mapped to pretty heavily. So for instance, all 3 groups mapped onto at least 5 of the 10 reconnaissance techniques. And we also see that group A mapped pretty heavily onto the exfiltration and collection tactics as well. And group B mapped a lot to initial access. So it's just kind of interesting seeing how groups mapped differently, even though they were all reading and mapping to the same exact case study. For instance, here, group A mapped to collection 11 times, whereas group B only mapped to collection 1 time. And then at the bottom, we see the total number of techniques that each group mapped, which really varies widely across the groups. A mapped 44 techniques, while group B only mapped 16. Those were the 2 ends. I think, Jamie, you mapped somewhere like around 20-ish of them.
I think that's about right. Yeah. And like I said, this is really fascinating to us because this is almost like a vignette of how industry consumes intelligence, where, think about these 3 different organizations, exactly as Rachel said, myself included. we had 4 different organizations that saw the same problem very differently and would probably come at defending this problem very differently. So it's fascinating to see not only where those differences lie and think about where they came from. As you can see, some of these deltas are a little bit more narrow, where we're kind of, there's a little bit of variance, but we're a little bit clustered, whereas there's others that seem like outliers. But the big central problem that we're kind of seeing here is that there's a lot of uncertainty in terms of how do we actually, how different organizations and how different groups would come about defending this. So as practitioners, especially in our seat of, trying to produce guidance, produce best practices, it is really, really valuable to see and be able to actually feel, where we can potentially, inject the most value in terms of maybe things that people can use, reference points people can use to, hopefully flatten this curve and make these numbers look a little bit more consistent. But like I said, these numbers are definitely very telling and kind of, I guess, a representative of a bigger, patterns that we've seen in industry.
Mm-hmm. All right, so that brings us to some of the lessons learned from this project. So the first, which we kind of saw in those differences in numbers, was that the tactics and techniques can be interpreted to fit social engineering behavior or for whatever audience it's being made for, really. So for instance, right, one group mapped to T1199, which is trusted relationship. And this is the quote they used for evidence. They said, "At this point, a little friendly chit chat ensued, and before you know it, they were laughing and exchanging pleasantries." Now, the definition on the MITRE ATT&CK framework website is a bit more technical than what this would cover. Students were able to learn to adapt and use the framework as it fits their needs and their case study. Actually, there was no wrong way to map if the group was able to provide that evidence and justification. They can interpret it to fit how they needed it. Right, Jamie's mapping didn't match any of the groups 100%, but it doesn't mean that Jamie's mapping was right and everyone else's was wrong. Everyone was able to justify their mapping. And this brings us to the second lesson learned, which is really to expand past the limits of a given framework and to widen one's scope to look at behaviors that fall outside of just the attack framework in this instance. So this case study project affirmed that social engineering is relevant both in the attack framework and within cybersecurity as a whole. The different mappings all showed that the focus of social engineering was pretty heavily on that reconnaissance stage. But it also showed that techniques used throughout a social engineering engagement can apply to techniques or tactics that are typically used for technical cyber campaigns. And these techniques and tactics that are commonly used for technical intrusions are also relevant in social engineering activity. Even when certain behaviors can't be mapped onto the framework, they're still important to examine to really properly be able to understand and defend against adversarial behavior. Then the third lesson learned is that by requiring students to reflect on, the richness of the case study and the usefulness of the attack matrix for such a case study, which what wasn't really shown in this, but it was another, small part of the project that the students did. It allowed the students to begin to learn, how to assess such resources. And because assessment of tools like this is really necessary to improve them and to improve how people understand adversarial behavior, it can lead to better defense against it. So it's really important they do that. And then there are, of course, some biases and limitations to keep in mind that Jamie will go over.
Yeah, we're not going to dive into all of them specifically, but like you said, Rachel, and this is kind of one of the reasons that we kind of crave these types of experiments, is seeing how different people see the same problem. Whether it's certain, as everyone could read the same paragraphs and certain things are going to stick out to them. But really what we want to make sure is that the right data points are sticking out to them. Obviously you want to exaggerate, as a cyber defender, you want to exaggerate your strengths. But that said, we also want to try to make sure that we can kind of, best we can work around these biases and make sure that, even if we're all kind of, have our own strengths and weaknesses that we want to play on, we at least have a clear picture. So it was really fascinating to see, especially like Rachel said, the multidiscipline backgrounds, how that actually comes to light in terms of not just seeing a problem, but, cascading down is how we'd actually address that problem, in different communities, that actually coming to light. But that said, Also, this was just one, really great data point, but one data point. So it's definitely a call to action on our side to, keep chipping away at this, really understand the problem, look at different case studies, look at different use cases, different perspectives, and really start to, exactly as Rachel's saying, drive home that point of, we know social engineering is, implicit, if not explicit, within these cyber campaigns and these behaviors. As both a, offensive practitioner and as a defender, how do we best communicate that towards, a wider community, not just people who understand this space, understand this research, but everyone who that could potentially benefit. So this is, like I said, really, really something that we're going to reference for a while in terms of really understanding, where those separations and where those deltas came from.
All right. And then finally, just some closing thoughts. So one of the biggest advantages that this mapping exercise provides is that students can use it as an aid. It allows them to understand, where they are in that intrusion chain and how techniques have helped the social engineer move from one tactic to another to get closer to, their objectives. And these insights are very valuable to organizations working towards understanding and defending against adversary campaigns. Mapping exercises and real threat intelligence provide insights into these tactics and techniques that are used by adversaries. And these can be paired with defensive countermeasures that can inform security decisions and operations. Another closing thought is that some of the impacts may not be represented in the framework, if they're intangible or don't align with the philosophy of how attack techniques are built. For instance, behavior that might include insider threats is a legitimate threat for almost all organizations, but the concept of insider threats, isn't really explicitly modeled into the current attack tactics and techniques. And this is the same with the impact of reputation damage on a company too. So in these cases, supplementing attack or using a use case specific framework could help capture some of those nuances. And then just a final thought here is that, we hope that other educators find this project as a useful template for how to design their own course projects that, are hands-on, teach students about both the MITRE ATT&CK framework and that mapping process, and expose them to the relevance of social engineering in cybersecurity. If we want schools to start teaching this in their curricula, here's one way to do it. All right, and thank you for having us.